Good morning students, welcome back to chemistry class. So the last class what we learned, do you remember? So the last class we studied about what? Types of mixtures, isn't it? Do you remember that? Two types of mixtures. What are they? Homogeneous and heterogeneous mixture. And also we studied about the difference between what? Mixture and compound. While learning the difference between, in that we have studied a point. Do you remember? The important point what we studied? The different components in the mixture can be separated by what method? Physical methods. Whereas the components present in the compound cannot be what? Separated by physical method. Only by the chemical means we can separate the components of what? Compound. Whereas mixture by physical method, isn't it? By hand picking, sealing, so many techniques to learn. So today we are going to see what are the techniques that are employed for the separation of homogeneous and heterogeneous mixtures. So what's our topic? Separation of mixtures. Okay. So already we learned what are the types? Two types. What are they? One is homogeneous. One is homogeneous mixture. The next one what mixture? Heterogeneous mixture. So two types of mixture. And now we are going to see what are the different methods, common methods that are employed for the separation of homo and hetero. Okay. First we can see what are the techniques that comes under homogeneous. Some of the techniques that you have given in your book. Okay. What is homogeneous mixture? What is homogeneous mixture? Yeah, it has uniform distribution. Heterogeneous, it does not have what? Uniform distribution, isn't it? So the techniques employed for the homogeneous mixtures are, the first one, distillation. Distillation process can be employed. Distillation, fractional distillation is there. Evaporation, etc. Crystallization is there. Chromatography. So these are the different techniques, okay, that comes under what mixture? Homogeneous mixtures. Okay, what are they? Distillation process can be employed. Fractional distillation. What is distillation? Okay, distillation means it is the combined process of evaporation plus condensation. Together only we will call that as what? Distillation. Evaporation plus condensation. Condensation means what? Cooling. Okay. So evaporation plus condensation together forms what? Distillation. Okay. For example, seawater can be subjected to distillation. That is to separate the liquid from a solution. To separate a liquid from a solution, we will employ what? A distillation. Next one what? Fractional distillation. If two liquids are miscible in nature, then we will use what? Fractional distillation. What is this miscible? Unmiscible as well as immiscibles are there. Miscible means homogeneous, immiscible means what? Heterogeneous. What is that miscible? Which blend with each other. Both the solid that mingle with each other or blend with each other or soluble with each other. That's why some solutions are called as what? Miscible liquids. For example, ink in water. What? Ink also liquid in nature. Water also liquid in nature. When we mix each other, they are uniformly distributed. Milk in water, ink in water. These are the examples for what solution? A miscible mixture. Okay, miscible liquids. Okay, such a type of liquids can be separated by employing the technique what? Fractional distillation. Okay, another example, for example, chemicals. Two chemicals. That is benzene and toluene. Benzene and toluene. Both are colorless liquid. But if both the liquids mix with each other, they are miscible in nature. You cannot separate it. Okay. So that such type of liquids can be separated by fractional distillation. Did you understood now? Miscible means two liquids that completely soluble with each other. For example, benzene and toluene, both are colorless liquids. If they mingle with each other, you can separate benzene separately, toluene separately by the technique called as what? Fractional distillation. The next one, evaporation. Common technique that you all know, isn't it? Evaporation commonly employed to separate solid from liquid. Next one, crystallization. So, okay, from the solution, solid particles are converted into crystals. Solid particles are converted into crystals. The solids that present in the solutions are crystallized forms. Crystallized means lattice. Well-defined arrangement of atoms. Well-defined arrangement of example, sodium chloride is what? A crystal, isn't it? Which is crystallized out from the sea water. The next one is chromatography. If the liquids contain one or more dissolved solids, then we will use the technique what? Chromatography. If your solution contains one or more dissolved solids, then we will use what? Chromatography. For example, plant pigment. Plant extract, if we take, it contains more dissolved solids, two or more dissolved solids. So that dissolved solids from the plant pigment we can separate by using the technique what? Chromatography. So one more time, homogeneous. Homogeneous means they are uniformly distributed, isn't it? It show only single phase. Okay, such a type of solutions or such a type of mixtures can be separated by employing these techniques. What are the techniques? Distillation, it is the combined process of evaporation and condensation which is used to separate liquid from the solution. Next one, fractional distillation. If both are liquid in nature and both are soluble with each other, then liquids are called as what? Miscible liquids. We will employ the technique fractional distillation. Next one, evaporation. Next one, crystallization. From the solution, solids are crystallized as a form a lattice. That is, for example, sodium chloride. There the atoms are well defined arrangement will be there. Okay. Next one, chromatography. If a solution contains more dissolved solids, that each type of solids can be separated from the solution by using which technique? Chromatography. Okay. The next one, we can see what are the techniques that is employed for heterogeneous mixture. The heterogeneous mixture, some of the techniques that is employed is, one is sublimation, centrifugation, separating funnel, magnetic separation, winnowing, sieving, filtration, etc. Okay. So the techniques that comes under heterogeneous mixtures are, what is what? Sublimation, centrifugation, separating funnel. These three techniques we are going to study briefly. Okay. Here we are going to study what are the techniques. We are going to study distillation, fractional distillation and chromatography. These three techniques we are going to see in brief. Here we are going to learn about sublimation, centrifugation and separating funnel. Okay. Other than that, magnetic separation. Magnetic separation means what? Okay, sulfur powder and iron fillings, if you mix together, take a magnet towards it, what will happen? All the iron fillings will be attracted toward magnet. That is called as what? Magnetic separation. Next one, winnowing. Winnowing means what? Okay, to remove the husk from grains, isn't it? Normally at the home also, while before cooking the rice, mother will remove all the husk that is present in the rice by what? Winnowing. Okay, that is called as winnowing. Next one, sieving. Next one, filtration. These are the common techniques which we will use in our day-to-day life. What are they? Magnetic separation, winnowing, sieving, filtration, and one more is there, that is decantation. Decantation also, after washing the rice, what mother will do, slowly she will decant the vessel, isn't it? So that high density particles will remain in the vessel, the water will flow away, isn't it? That process only we call it as what? Decantation. Okay, so magnetic separation, winnowing, removing the grains from the husk. Next one, sieving. Next one, filtration, filtering. Next one, what? A decantation. Okay, these are the techniques commonly we will use in our day-to-day life. Other than that, what are the techniques are there? Sublimation, centrifugation and separating funnels. Okay, so in our chapter, we are going to discuss about these three topics and here three topics. Today we can see what is sublimation. What is sublimation? Okay. So separation of the mixture. First technique we are going to see is sublimation. This technique comes under where? This technique, this process or this physical method is used to separate which mixture? Heterogeneous mixture. It is used to separate what mixture? Heterogeneous mixture. What type of heterogeneous mixture means? Solid from solid. It is used to separate solid from solid. Ammonium chloride also salt. Okay. Sodium chloride also salt. Okay. For example, so sublimation, heterogeneous. It is a technique comes under heterogeneous mixture, and it is used to separate solid from both the components are solid in nature. Okay. For example, ammonium chloride. Ammonium chloride is also salt. Sodium chloride also salt. Sodium chloride also salt. See, both are solid crystals. Both are what? Solid crystals. Now, unfortunately, both mingle with each other. Both are mixed together. We want to separate ammonium chloride and sodium chloride separately. By hand picking, it's very difficult, isn't it? Filtration also cannot be employed. Decantation cannot be employed. So, what technique we can use means sublimation. Why means? See here, this ammonium chloride that has the property of sublimation property. It has one property. Because while heating, this ammonium chloride can be converted into gaseous form. See, while sodium chloride on heating, they cannot be converted into, it won't undergo any physical change. See, here ammonium chloride also salt, sodium chloride also salt, both mixed with each other. Now we want to separate these two salts, separate, isn't it? Am I right? So, what the technique we can use here means both are solid and solid crystals. We are going to employ which technique? Sublimation. Why sublimation we are employing means this ammonium chloride, we know the property of this ammonium chloride, on heating they can be converted into gaseous form. But at the same time, sodium chloride on heating there will be no change. On this principle, we can employ what technique? Sublimation. This undergoes sublimation, this does not undergo sublimation. So these two mixtures this mixture can be easily separated. Okay, ma? So what is sublimation? Sublimation means any solid substance that is directly converted into gaseous state. Okay, any solid substance that is directly converted into gaseous state on heating without undergoing any physical form. Without undergoing liquid state. Without undergoing liquid state. So these solid particles, any solid substance on heating, they will be converted what state? From solid to directly gaseous state without going the intermediate, that is liquid. Normally solid, liquid, gaseous form, isn't it? Here some solid particles on heating directly changes into what state? Gaseous state. And this gaseous state on condensation. Condensation means what? First itself I said, what is that? Cooling. Condensation means what? On cooling, this gaseous state molecules can be again converted into solid state. And this process is called as what? Sublimation. This process is called as what? Sublimation. Okay. So what is sublimation? Solid on heating, directly converted into what form? Gaseous form. That does not undergo the state of liquid state. Again, this gas or vapor on condensation, that means cooling, again it forms solid. This whole process is called as what? Sublimation. Okay. Here ammonium chloride shows this property, whereas sodium chloride does not show this property. So we can easily separate ammonium chloride and sodium chloride from by the help of sublimations. Now we can see the diagrammatic representation for sublimation. See, for example, we can take ammonium chloride and sand. Ammonium chloride and sodium salt, or you can take ammonium chloride and sand, camphor and sand, iodine, etc. Other examples, instead of ammonium chloride, you can take iodine, camphor, etc. Okay, iodines are camphor. Camphor commonly, you know what is the chudam. Okay, commonly what is that chudam? Okay, you all know, isn't it? White color camphor. Okay, that can be also used instead of ammonium chloride, and you can do this experiment at your home. Okay, and you can check it. Okay, ammonium chloride and sand. Now we have taken what? Ammonium chloride and sand. Either you can take iodine and sand, or camphor and sand, or camphor and table salt at your home also you can take. Okay, camphor will be available now. Plus you can take sodium chloride salt. Okay, for this, first we need a burner. We need what? A burner. Okay, for of heating, we need a burner. Keep a stand over the burner. Okay, keep a tripod stand. In that stand, you take a dish, china dish, so that you can heat it for a long time. China dish. Okay. In this dish, you take the mixture. What is the mixture we have taken? Ammonium chloride and sand. Take in the dish. Okay. Close this dish with a asbestos sheet. Take a asbestos sheet and keep over it. And this asbestos sheet contains so many holes. That is called as perforated asbestos. Perforated means what? Which contains small holes on the sheet. Okay. So it contains so many holes. Okay. Small holes on the sheet. Okay. Now you heat the burner. Okay. Now we begin the heating process. While heating this ammonium chloride, the ammonium chloride crystals. Okay. While heating, so we have sand as well as ammonium chloride. So this ammonium chloride salt, it absorbs the heat energy. It absorbs the heat energy, and the molecules that are tightly packed in the crystals, this energy is enough to overcome the bond. And the molecules that are present in ammonium chloride become loosely packed. So more loosely packed means what state that on? Gaseous state. Okay. So this ammonium chloride absorbs the heat energy. The energy that is coming from here, it is enough for them to overcome some bonding between the molecules and they become loosely packed. So all the ammonium chloride will be converted into what form? Gaseous. They started to convert it into from solid state by absorbing the heat energy. They will overcome the interactive force and now they converted into what? Gaseous. So we need to trap these gases also. We want to separate both, isn't it? Here, what is the impurity? Sand is the impurity, and what is the useful substance mixed along with the sand? Our ammonium chloride. So we want to trap what? The gas. Okay, to separate the ammonium chloride. So what we can do? Take a funnel. Okay, take a funnel and keep over this. Okay, and keep over the asbestos sheet. Fully, it has to be covered. We know funnel. At home you can see the funnel, isn't it? Both the sides are opening. So we have to come. This side was closed. One of the side, okay, one of the opening has been closed by cotton plug. So close one of the opening with what? Cotton plug or wool. You close this to prevent the escaping of what? The gas. Okay, because here ammonium chloride now started to convert into what? Gaseous state. So the gases are coming out through the holes, and these gases are trapped or captured by an inverted funnel. Okay, by keeping the funnel inverted. So both the side openings are there. Through one opening gases will enter. So through this opening should not escape. So cover this or close it with cotton plug or wool. Okay. Again this funnel. This is inverted funnel. So now the gas vapor and the fluid is inside the funnel. Okay. Now the funnel is subjected to condensation. Now the funnel is subjected to what? Condensation. Condensation means what? Cooling, isn't it? Again on cooling, cool this funnel. Okay. Again on cooling, what will happen? Again our ammonium chloride forms solids. Again our ammonium chloride is converted into what? Solid. This gas directly converted into again its solid state by the process of condensation. So now our dish contains what? So a dish closed funnel, isn't it? Now our dish contains what? Sand. After sublimation, the dish contains what? Sand, and our funnel contains what? The condensed ammonium chloride. Condensed what? Ammonium chloride salt is present here and the impurity is present in the dish. So we have separated. Like this you can separate sodium chloride and ammonium chloride, camphor and sand, iodine and sand, etc. In this both the solid, one must undergo what process? Sublimation. Then only we can employ the process. What process? Sublimation. Do you understood? Once again. So what is sublimation? Heterogeneous technique What is the definition for sublimation? The conversion of solid particle directly into gaseous without undergoing liquid state. This gas, again on cooling, they form what substance? A solid substance. This process is called as what? Sublimation. To undergo this process, among the two solids, one must have what process? One should be sublimized. Okay. Other example for sublimation is iodine, camphor, etc. Okay, well, did you understood what is the meaning of what is the process of sublimation? Okay. Okay. And this comes under which technique? Heterogeneous, to separate solid from solids. Okay. This is important 2-mark question. The definition is very, very important. Okay, ma? So the next class we will learn about the other 2 techniques which comes under the heterogeneous, that is separating funnel and centrifugation. Okay. At the book back, Roman number 5. At the book back, Roman number 5, you have a question define sublimation. Okay. So under the heading sublimation, you mark first 4 or 5 lines. It is there. Sublimation is what? The direct conversion of solid from what? Gas without undergoing a physical state. Again on cooling, the vapor again condenses into solid. This process is known as sublimation. With the example, mark as any one of the example you can mark either iodine or camphor, etc. Okay. Thank you, students. So learn this question 2 mark. Okay, next class we will discuss about the next 2 topic. Thank you.